Hello and welcome to the presentation of the paper titled as TaskAllocator, a recommendation approach for role-based task allocation in Agile software development. My name is Saad Shafiq and my co-authors are Atif Mashkoor, Christoph Meyerdom and Alexander Egid from Johannes Kepler University in Linz, Austria. In typical Agile software development, these tasks may represent or refer to a user story or an issue, but not limited to only these terms. These tasks are manually allocated by the project managers to respective team members based on their roles, workload, and domain knowledge. Studies have shown that there are certain challenges involved in distributed Agile software development. Some of them include manual tasks allocation, poor communication among stakeholders, language barriers, incompatible time zones, and above all, the lack of knowledge of project managers about team members due to their scattered locations. Besides that, there is also a presence of generalists in the team, also known as multi-skilled individuals. These individuals continuously change their roles in the team based on the requirements, which poses many challenges to the direct allocation of tasks to individuals. For example, an individual may leave the project in the middle, or the individual may not be optimal for the task at that time. In case of incorrect assignment, the reassignment takes considerable amount of time. Therefore, the direct allocation of the tasks to the individuals may not be feasible in this case. For this purpose, we aim to propose a dynamic role-based task allocation approach using machine learning. So the overall goal of this approach is to recommend the most befitting roles for the incoming tasks. So in our approach, we use textual features of tasks along with pre-trained vectors as input to the training of our machine learning models. So these pre-trained vectors are obtained from Stack Overflow dataset, which comprises of concepts, relationships, and vocabulary specific to the software engineering domain. The reason of using pre-training is to prevent model from learning from scratch, and it also helps in the model generalization. After the training process, we perform k-fold cross-validation, which is considered to be a standard machine learning practice in order to avoid overfitting problem. We also evaluated our obtained machine learning model on a held-out validation set. So apart from this, we also added a preference mechanism where if the most suitable role is not present in the project, then the role which has the highest confidence in the project will be selected for the recommendation by the model. Moving towards the case study, for the data extraction part, we have employed the Tiger repository as our primary source. We have extracted 10 projects based on a predefined project selection criteria. These 10 projects comprise of 1226 tasks, user stories, and issues combined. For the data pre-processing, we first removed the stop words from the text, which had no meaning in the learning process. We then performed tokenization to convert the text into sequence of integers. For the implementation of the approach, we performed the training and validation of the machine learning models. We also conducted a benchmark study in order to compare the performance of various machine learning models for this purpose. We have utilized 3 neural network models and 5 conventional ML models, which are typically used to address multi-class classification problems in literature. Moving towards the results, so we evaluated our approach in both the cross-project setting as well as the individual project setting. For the cross-project setting, the results of our study show that LSTM model without the pre-trained data outperformed the rest of the models with the accuracy of 69.3%. Whereas in conventional machine learning models, multinomial naive Bayes model has performed better than the rest with the accuracy of 66.3%. For the individual project setting, LSTM has outperformed the rest on majority of the projects. We also developed an integrable JIRA plugin in order to demonstrate the applicability of our TaskAllocator. This plugin basically recommends a potentially suitable role whenever a new task is added to the project. As you can see the figure on the right. We also made the source code of this plugin publicly available and can be accessed through the link below. In order to further the research, we have made the extracted dataset publicly available for the research community. The link to download the dataset is mentioned below. Moving towards the key findings of this study, TaskAllocator leverages the LSTM model in order to recommend the most befitting role for an incoming task. The results of the benchmark study show that employed LSTM model outperformed its alternatives with an overall accuracy of almost 70%. While in conventional machine learning models, multinomial naive Bayes model has outperformed the rest with an accuracy of 66.3%. Moreover, the flexible architecture of TaskAllocator allows it to integrate with any machine learning neural network model that demonstrates an improved performance in the future. Moving towards the practical implications, for project managers, TaskAllocator provides the capability to identify most suitable and befitting roles in distributed teams for an incoming task beforehand, which is very crucial, especially for agile ceremonies such as sprint planning. For researchers, the benchmark study conducted in this research would help in understanding the prediction capabilities of machine learning models in this area. And also the textual features of the tasks could be deemed as an effective predictor in identifying coarse-grained roles in the team. For conclusion, we have proposed a recommendation approach called the TaskAllocator in order to solve the task allocation problem at a coarse-grained level. We also developed a corresponding JIRA plugin in order to demonstrate the prediction capability and applicability of the TaskAllocator. Besides that, we also performed a benchmark study in order to determine the performance of TaskAllocator by comparing it with contemporary neural network and machine learning models. Finally, we made the dataset, the extracted dataset, publicly available for the research community. With that being said, I thank you all and will be happy to answer your questions.
Back, it's me here again, Fabio, with Saad. Thanks for watching the video. There seemed to be one question from John Knoll. John is asking, sometimes one wants to assign tasks to people that don't necessarily have the necessary skills to give them experience and help them learn. Could you add this capability to your approach? Thanks, John.
I mean, if I understand this question correctly, one wants to assign tasks to people.
So I think basically your task allocator is trying to match, task with best fitting people in terms of skills. Sometimes it is probably saying you don't want the best fit because you want to give space to someone who's missing the skills in order to develop those skills.
Yes, but actually the approach works based on the historical data. So if there are the roles that are assigned to specific individuals, then the model will actually learn from only those textual features and roles. So it cannot incorporate skills or the approach itself cannot do that.
Yeah, although this probably would be confusing for the learners if you have both. If you have instances of best fit and worst fit at the same time, it might be confusing. So, but the answer is it can be done. Another question from Maria Pasivara: why would task allocation be needed in agile teams when teams should be self-organized and team members should pick up tasks by themselves?
I mean, if in geographically distributed teams, usually the project manager in agile teams assign roles to the teams. So in that case, this approach will not work if the the individuals are picking the tasks themselves. But in usual case, studies have shown that the tasks are usually assigned. First, the story points are defined to each task, and then the managers decide who should be allocated to that task.
Okay, so one question that I have is you sample project from the Taiga repository, if I remember correctly. So since it's lesser known than JIRA and GitHub, what kind of project actually you sample from those? What are the characteristics? I remember you sampled 10, if I remember correctly.
Yes, so we extracted the projects from Tiger repository. The selection based on a predefined selection criteria, as mentioned in the paper. The projects were mainly on, for example, browser-based softwares, and the details of those projects can be seen in the dataset as well. And the selection is based on how many likes the projects have. So the projects with top likes and with most activity performed recently have been selected, and the search was stopped when we had 0 likes and activity on that page.
Okay, but so most of the projects were in web domain, web development.
Yes, these are web domain, and some were smartphone applications.
Smartphone applications. So don't see. I have another very quick one. If you can answer, I think that your assessment of the learners were based on accuracy, but I saw that the distribution of role labels were not very equal. I mean, the developers and stakeholders were many more than the others. So I wonder if you could have used another performance metric that could account for the imbalance of the data, like weighted accuracy, or I don't know, the weighted and the micro and macro F1. And if you think that this might have an effect on the assessment.
I mean, yes, we could have used that metric as well, but I don't think that the difference would be that much in that case as well.
Okay, so we have 30 seconds left. Let's thank Saad again. Thank you, and let's move to the other paper. The other paper, the video that is going to play is "Do Communities in Developer Interaction Network Align with Subsystem Development Team?" presented by Usman Ashraf from the University of Johannes Kepler University in Austria. I will see you after the video. Thanks again, Saad.
Thank you.